It's Don here from the board. Thanks for coming along and checking out this video. So today I'm just doing a follow-up chat in regards to the Switchbreaker Inera. So it's probably been one of the more successful videos that I've done in recent times, and it's had a really great, amazing response, to be honest, and I'm kind of flattered with how many people have actually taken up the concept and the design, and I can see from the referral link how many people have actually gone out and bought the little motor that I used in my design. Now, at the same time, I've had a lot of people contact me and ask me questions and try to get some help and feedback about this particular design and setup. So I want to talk about that. Let's talk about that. So what we're talking about in the Switchbreaker design here is the use of this tiny little motor. I guess it probably isn't obvious and evident for people who don't do a lot of prototyping and experimental design work, is the fact that prototypes and experimental design, while you test them to be functional, unless if you do extensive amounts of testing and extremely prolonged amounts of testing, you're not going to necessarily know and come across a lot of problems. Some of the things that seem to be coming up is the fact that this motor is failing very quickly. And that honestly does not surprise me in the least. And I do want to apologize about that because I didn't really talk about that in the earlier videos. Now, it's a tiny motor. It's an incredibly small motor. It's an incredibly cheap motor. It's a $10 motor. It's not a $30, $50, $100 motor. And at that kind of price range, common sense, I would have thought, unfortunately, I can't speak about other people, and this is not to criticize people who've actually experienced problems, but there's a lot of things out there in the world that you get what you pay for, right? So when you pay $10 for a tiny little motor, you can't expect it to have a massive life expectancy. Now, there are others in the community who have revised and updated the concept and design of the Switchbreaker. They've just taken some of the components of it and the thought process behind it and turned it into their own. And they've gone with significantly bigger, stronger motors to power the drive shaft. And they don't generally have any issues because obviously they've upscaled, upsized. Now, the two most common things that I've come across on the feedback that's been given to me and queries is the motor is just failing straight up outright when it tries to turn, or that it gets extremely hot, or it's failed after running for an X amount of time. And I kind of want to address that. So you'll notice on this, it's wobbling heaps already because it's a little gearing, right? So I'm just going to switch over to the monitor so you can see the close-up pictures from the actual product listing. Okay. Whoa. Honestly, what am I doing? Good question. Well asked. Why is that going to my right monitor? Okay, so obviously my monitors are picking up the wrong device. I've recently actually changed video cards, and I think that's what's kind of happened to it. It's actually changed the display. There we go. Okay. All right. So here is the motor, and you'll see it's a series of tiny little gears because the primary driver here is that it's driving a very small gear, and it has a series of reduction gears to add torque to the drive shaft. So on mine, after the amount of testing that I've done with it and fiddling with it, it's already extremely loose. It wobbles heaps. I would expect that mine will probably fail at some point too. So that's the first thing. you have to understand the mechanics behind of what's going on here and potentially why it's going to fail. So as part of fitting it, the amount of slack and slop in the actual gearing, the meshing, the quality of the build, that's a problem, right? The second point to this is the amount of power, electricity-wise, that is going through this. So somebody told me, and they showed me pictures, which was absolutely amazing, that their motor had actually melted the base plate, that the motor was housed in. The PLA was melting from the heat of the motor. It was running for an amount of time and then it started to melt the plate. That is crazy. It gets real hot to be able to melt that, right? So if you're running at 12 volts, it's meant to spin under load at about 60 milliamps. And through discussion with this person, they actually had a 1 amp 12 volt power supply, which meant if there was any binding, if there was any extra resistance against the system and the drive shaft wasn't able to spin freely, it's going to draw as much current as possible. And you'll see here that the stall current is meant to be less than 1.1 amps. So if there was a lot of resistance that was happening within the system, it can draw up to an amp easily. And for the size of what it is, and for the fact that it's generating heat because the gears are also moving and meshing and there's friction going on in there, that motor got super hot. Now, if you got a slightly poorer quality constructed one, and that's just luck of the draw with a cheap mass manufactured product of this nature at $10, right? When it overheats, stuff is going to fail. When it overcurrents, it overheats. Stuff is going to fail. The windings in it are probably going to burn out. The wiring, the joints, the connections, the soldering, all of those things can fail very quickly in the, I suppose, right, but at the same time wrong conditions. Now, because of that, I want to go back to my video in discussing the context that if you watch my video, this starts to run at about 3 volts on just the 2 racks. And while I never fully populate that in the video, obviously you need to up the voltage to get more speed to the full RPMs, and at the same time to overcome the spring weight that you're loading into it. Now, I was using Gateron Blues, so they've only got 45 gram weight. But if you're using something that's a lot firmer, a lot stiffer in terms of spring weight, that's providing potentially more resistance against this drive shaft. And they're all things that you have to take into account. If you're going to run something at its maximum capacity, like at 12 volts, at full speed, its lifespan can drastically reduce. So if you've still got a motor and it's still working and it does start to run hot and you want to prolong its longevity, well, the best thing that you can do is to actually turn down the voltage, turn down the speed if you have that choice. Because while it might take you longer to actually get to the number of key press wear-ins that you're after, you're more likely to get your value out of the motor by keeping the motor alive than running it faster and potentially burning it out. Now, the person who experienced the really high temperatures that was melting the PLA, their solution, which theoretically should actually work, is that they're going to put up a current reduction by adding a resistor into it, which will drop the current draw that the motor is permitted to pull. So we worked out, and I think my mathematics might be correct, that a 2000 ohm resistor, a 2K ohm resistor, will drop the amps coming out the 1 amp down to the 60 milliamp maximum. So it might actually cause the rig to stall, but at least it shouldn't overdraw and burn out the motor. So that's a solution that's possible if you don't have an expensive variable power supply that, for example, I used in my video. So I just wanted to talk about that. I wanted to cover off on the fact that if you are intending to just straight up buy and print exactly the same setup that I had, some of the pitfalls that are involved. One, yes, it's a cheap motor. It's experimental, right? It's prototyping. It's a proof of concept. Two, running it at full maximum speed and power will shorten the motor's life. Three, fitment and the quality of the actual motor itself in regards to how long it's going to run and if it jams and stalls and overcurrents and burns out are things that you have to think about. Now, in this design, I can actually pop this out, right? So in this particular design, I can actually pop that out, and if I need to, I can add lubricant in there. I can fill that with grease to help it potentially run a bit better. I haven't done that, but that's just something that I potentially could do if I was trying to get maximum life out of this. But I don't really care about breaking in my switches as such, and I'm certainly not offering as a service. So it's not something that I'm going down the depths of doing, but it's something that you should think about if you want to. Just some machine oil, a couple of drops here and there would probably make a big difference. The actual hole size in the plate to make sure that this drive shaft is not binding at all. You don't want to open it up and so it just spins. You want to make sure that as this whole assembly is rocking about and moving about, it has as much possible clearance safely that it's not going to add extra binding to it to increase the torque load and therefore the current draw on that motor. So, I just wanted to clear that up. I wanted to just do this video so that people know that I have heard their concerns and I have thought about it, and these are the potential reasons for it. And if you are new to this switch breaker and the design and the videos related to it, but you haven't put one together, this is just food for thought, so that if you do want to put one together, you might want to reconsider what equipment you're going to put together with it. Go with a bigger motor, with a bigger spindle drive, something that's got more torque on it, or maybe something that's current limiting. All of those options will help reduce the likelihood of you experiencing problems like what this setup, as a prototype, as a proof of concept, you might experience. So there you go. That's it. If you do have any more questions in regards to the issues that you might come across on this, please do let me know, and I will try and respond to you as best as possible. So thank you, of course, to everybody who's supported this design and this prototype and the feedback. I really appreciate it, and I hope you all have the best in breaking in your switches. So with that, I'm going to wrap up. Thanks very much for checking out this video. Subscribe, bell button, you know the drill. And of course, as always, until next time, happy clacking.